Fantastic. Okay. All right, so guys, I think I'm recording this, but anyway. We'll see.
Calculator time.
No.
Actually, the goal is to be able to do a lot of these examples without a calculator because you are going to be using the formula, okay? So not to say, keep your calculators away. I'm just saying,
Keep them away.
yeah. Anyway, so we've got a few more formulas here. These are called compound angle formulas. These are called double angle formulas for obvious reasons. These are when you are finding the sine, cosine, or tangent of this angle plus this angle or this angle minus this angle. And there's some cool creativity there to be able to get exact values of angles that are not our normal special angles. So that's going to be what those are used for. Some of you noticed as you came in that there's a funny symbol here and here, right? Okay. What that means is, okay, look either at your paper or up here. Cosine of the angle A plus B will be cosine A times cosine B minus sine of A sine of B. Now, if you are doing the difference of two angles, then cosine of A minus B is cosine A cosine B plus sine of A sine of B. So that is the reason, and so same here, if we're adding, then up here it's addition, but down here it's subtraction. That's how you read that formula. Are y'all okay with that?
Yeah.
Okay. Double angle formulas, you are going to be, yeah, okay. This is kind of cool, and this one's kind of cool right here, but are you looking at this and saying, ooh? Just making sure you understand. This is one way to rewrite. Why is that all wiggling? Anyway, happy hour started early. Just kidding. Oh, good. That's recorded. Anyway, cosine of 2 theta is the same thing as this.
It went wobbly again.
Or, if you prefer, that is the way you can do it. It's the cardboard underneath. That's why it's all wiggly. Anyway. Because the papers tend to, compact or expand, and it makes it blurry. Like it'll bring it too close or not. Anyway. So when you look on your formula booklet and it says cosine of 2 theta, and you're like, well, crap, which one do I use? Well, it depends on what you know and what you need to know. Or if you're doing a proof, it kind of depends on what the final product needs to be. I may choose this one if the entire problem only has to do with cosine of theta, then I'm going to choose this one. If there's a mixture of sine and cosine, then I'm going to choose this one. If it's all sine, then I'm going to choose this one. So does that make sense? Sort of? Okay. All right. So let's look at what in the world is this. Okay. And this is in degrees. So little escape from radians for a second. Okay. Now, 75 degrees was not one of those on our unit circle, was it?
No.
Okay, so is 75 degrees, can we put two angles together to make 75 degrees? So this is the sine of 30 plus 45, right?
Why are we going to? Oh, because they're actually.
Right. Because we know how to find the stuff with this. Anyway, now I am using my formula right there on your sheet. So the sine of 30 plus 45 will equal the sine of 30 times the cosine of 45 plus the cosine of 30 times the sine of 45. So I'm literally just using this formula right here. Did everybody follow what I was doing? Okay. So it would help if we knew what these were. So this is a trip back to your unit circle. What is sine of 30? Is it 1/2? Okay. What is cosine of 45? Oh, y'all do the simplified version. If you do 1 over square root of 2, that is fine. Or you can change it to that. Either one. Plus, okay, what is the cosine of 30? And what's the sine of 45? Which looks like this is going to be, this is just square root of 2 over 4. And this would be square root of 6 over 4. So, and that's what we're looking for, right? It actually said what it was going to be, and we just showed it. Oh my gosh, it's lunchtime. It's dinner time.